Hey everybody, so in this section we're going to talk about slope. So the first thing I want to do is review the stuff that you should know about slope from your Algebra 1 class, and then we'll go into some more difficult examples. Okay, so the first thing I want to do is remind you that the idea of the slope of a line is to measure the steepness. Okay, and then the definition. Okay. Okay, so remember we traditionally use the variable m to stand for slope. Okay, so this is going to be the change in y over the change in x. Okay, so the vertical change over the horizontal change. Now you've definitely seen this before. What you might not have seen is the notation that looks like this. Okay, this little triangle is a delta. Okay, and it means change. Okay, so we'll see this notation a lot for slope, change in y over change in x, right? Or you could say delta y over delta x. Okay, all right, so let's do a little review example of using a graph to find the slope. Okay, so the first thing we're going to do looking at this equation is find the intercepts. Okay, so this is using the skills that we refreshed in the last section. Okay, so for the x-intercept, we're going to let y equal 0. Okay, now this would give me 3x equals 12 or x equals 4. Okay, and I'm going to remind you again that an intercept is an ordered pair, so we'll list this as the ordered pair for 0. Okay, for the y-intercept, we're going to set x equal to 0. Okay, that gives me 4y equals 12 or y equals 3. Okay, and I'll list that as my ordered pair 0, 3. Okay, so that's the answer for part A. So then for part B, we are going to graph using the intercepts. Okay, so let's grab a piece of graph paper here. Okay, so the numbers aren't all that large, so we're just going to draw our axes here. Okay, and then the ordered pairs were 4, 0, 1, 2, 3, 4. Okay, and then 0, 3, 1, 2, 3. Okay, and then we can graph by connecting them with a line. Right, this is what we talked about in section 1.2 when we reviewed graphing using the intercept method. Okay, so that's part B. Now for part C, we want to use the graph to find the slope. Okay, so here's what we're going to do. Remember, this is change in y over change in x. Okay, so we are going to look at our graph at our 2 points, and we're going to find the change in y and then the change in x. So we're moving from this point here to this point here. Okay, So to move from here to here, I'm going to go down 1, 2, 3. So my change in y is going to be down, right? Negative meaning down, 3. Okay. Then I'm going to look at my horizontal change, right? So I went down 1, 2, 3, and now I'm going to go right 1, 2, 3, 4. Okay. So right is the positive direction, and I went right 4 units. Okay, so my slope would be negative 3/4. Okay, all right, now that we've reviewed that, let's look at an applied example. Okay, a worker's pay is given by P of T equals 11T, where T is hours worked and P of T is her pay. Okay, so we're going to make a table with 4 points. Okay, so we're going to set up the table like this, with our input variable as T and our output variable as P of T. Okay, so now we're going to have 4 points. You can either pick values for T or you can pick values for P of T. I'm just going to pick values for T that I think are easy to plug in. So I'll do 0, 10, 20, 1, 2, 3, and 30. Okay. So if you plug in 0 for T, 11 times 0 is 0. 10 times 11 is 110. Okay. 220, 330. Okay. So there's my table with 4 points. You didn't have to choose these values. You could have chosen anything. Okay. All right. Then the next part says use your table to graph. Okay, so let's grab some graph paper. And we're going to make a graph. Okay, so we have to go all the way up to 330, so we're going to make a relatively tall graph. Okay. I do still want it to fit in the window here though. Okay, there we go. Okay, now my T values, remember your input always goes here, where your output always goes up here. Okay, so my T values were 0, 10, 20, and 30. So I'm going to go by tens here. So this would be 10, 20, 30, 40, 50. Okay. And then I'm going to see how I should do this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so remember I'm going to take the biggest number, which is 330, and I'm going to divide it by the number of lines. Okay, and I get something that's bigger than 23. So I would normally, I have to choose something larger than 23, so maybe 25 seems like a reasonable scale. So 25, 50, 75, 100, 125, 150, 175, 200, 25, 50, 75, 300. Okay, this is 325. All right, so now we're going to mark our key points. Okay, so we had 0, 0, which is here. We had 10, 1, 10. So 10, 1, 10. Okay, I had 20, 220. So 20, 220. Oops, that should be here. Okay, and then I had 30, 330. Okay, now you can see these are all lined up in a line, so I'm going to connect them with a line like this. Okay. All right. Now this says use 2 points on your graph to find the slope. Okay, so this is what we practiced in the first example. So we're going to do change in y over the change in x. Okay, so right now, looking at this graph, I want you guys to pick 2 points and to find the slope. Okay. All right. So right now I'm going to pick these 2 points. Okay. So I'm moving from this point to this one. My change in y, I'm going to go from 0 to 110. Okay. So I'm going up 110. Okay. And then, okay, I'm going to look at my change in x. So here I'm going from 0 to 20. Okay, so that would put me, oh, I'm sorry, 0 to 10. Okay, so that would put me at 10. Okay, I'm going to reduce my fraction. I'm also moving right, so that's positive. This would give me 11. Okay, well, what if you didn't pick these 2 points? It just said pick any points. Okay, so what if I picked this point and this one? Okay, well, my change in y, okay, from here to here would be from 0 to 330, so my change is positive 330. Okay, then my change in x is going from 0 to 30, so my change is 30. Okay, when and I'm going to the right, so that's positive. Okay, when I reduce this, I get 11. Just like we got using the first 2 points. Okay, what if I picked this point and this one, and what if I actually went this way? Okay, so this point I'm going from 220 down to 110. Okay, so if I'm going from 220 to 110, I'm going down 110. Okay, then I'm going from here to here, so I'm going from 20 to 10, so I'm moving left 10. Okay, negative divided by negative is a positive. 110 over 10 is 11. Okay, so I'm sure you guys get the idea here. No matter what point you choose, what pair of points you choose, or which direction you go, this way or this way, you should always get 11. And this is actually the defining feature of what makes something a line, is that the slope between any 2 points is always the same. So no matter what points you pick or which direction you move, the slope when you find it is always the same. Okay. All right. Now let's ask this question about this word problem. What does the slope mean? Okay. So remember the y value, right? The vertical value is her pay. Okay. Right. This is like 11 over 1. Okay. And the x value is really a t value, right? It's really the time that she's worked. Okay, so this says her pay is $11 for every 1 hour. Okay, so we would say, what does the slope mean? She is being paid $11 per hour. Right? The reduced version, right? Because you could say she's being paid $110 for every 10 hours, but the reduced version will tell you how much she's paid for every 1 hour. Okay? Her hourly rate. So she's being paid $11 per 1 hour. Okay? All right. Let's look at another example. The distance in miles covered by a cross-country runner is given by d of t equals 6t, where t is the time running in hours. Okay, so d is the distance, t is the time. So again, we're going to make a table of 4 points. Okay. You can pick your own points here. Okay, because this is someone running for hours, I'm going to pick some pretty small points. Okay. And then I'm going to fill in here. So if I put 0, I get 0, 1, I should get 6, 12, and 18. Okay, and I'm just getting those by plugging in the t values here. Okay, Part B says graph using the table. Okay, so we're going to graph using the table. Okay, the biggest value was 18, so maybe we'll just try to make this be 19, 18, 17, 15. 10, 5, okay, there we go. All right. Maybe I could have made it a little bit smaller, but that's all right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19. Perfect. Okay. So now I'm going to mark my points. So I had the point 0, 0, 1, 6, okay, 2, 12, and 3, 18. Okay, now you can see all of those points do fall in a line. Okay, so I'm going to go ahead and graph them. Oops, this point should actually be here. Okay, I had it marked at 418, but it's really 318. Okay, so I'm going to take those points and I'm going to connect them. Okay, so that's part B. Part C says use 2 points on the graph to find the slope. Okay, we know from the previous example that it doesn't matter which points, so I'm just going to choose these two. Okay. Now, I'm going to do, again, the change in y over the change in x. Okay, so if I look at this graph, I was using these 2 points. Okay, the change in y is going from 6 to 12. So my change is going to be 6, and it's going up. So I'll have positive 6. Okay. And my change in x, okay, going from here to here, is only going from 1 to 2. Okay, so I'm still moving to the right, which is positive. I'm only going to get 1. Okay, so this would be 6. All right. Now it says, what does the slope mean? So remember what the y-type variable is. It's the distance. Okay, so she is increasing her distance 6 miles for every one, what was this? Remember the x-type variable is time. So she's going 6 miles for every 1 hour. So what does that mean? We would say they run 6 miles per hour. Okay, right, their hourly speed, 6 miles per hour. Okay. All right, so there's some applied examples. We're going to do one more applied example, and then we're going to talk about some function things. Okay. All right, so okay. So I want to explain this type of question. This is a common type of question, but if you haven't seen this before, it really would be hard to solve it. Okay, so the first thing that I want you guys to know is that when you see this where it says 10% grade, what that means is that the slope is 10%, right? Okay, and how else can we express a percent? We can express it as a decimal, but in terms of slope, we normally see a fraction, right? So let's express this percent as a fraction, 10 out of 100. Okay, so that's what it means when you see something as a 10% grade. That means the slope is 10 over 100. If it was a 20% grade, it would be 20 over 100. Okay, now remember, slope is, we know how to write slope, is equals 10 over 100. Okay, now our slope is change in y over the change in x. Okay, now we're going to look back at our question and we're going to look for either the change in y or the change in x. Okay, now here it says the horizontal distance of 25 miles. Okay, now which variable is associated with horizontal distance, y or x? Yeah, it's x. So we're going to fill in the change in x as being 25 miles. Okay, then when you look at the question, it's asking for change in elevation. So that's exactly asking what is the change in y, right? Elevation means up and down, so does y mean up and down. Okay, so now I have something that I know how to solve, so I'm going to cross multiply. Okay. I'm going to divide both sides by 100. Okay, so my change in y is 2.5. So what is the change in elevation? The change in elevation is 2.5 miles. Okay, so that's our last applied example. Let's do one more example that has to do with slope, but it also has to do with functions. Okay, so we're going to answer part A first. Okay, So part A is which of them represents a function. So if we're looking at these three tables, we want to know which of those three, if any of them, is a function. Okay, so remember what you're checking for when you're checking if something is a function. Remember, this is from 5.1. Okay, we're saying, does each x value have one corresponding y value? Okay, so if we check the x value -2, it does have a corresponding y value, but it seems to have two corresponding y values, right? We have this and this, so we would say that this is not a function. Okay. For part 2, we're going to check each of our x values, see that it has a y value. Okay, and we can see that each of our x values has exactly one y value. So that means, yes, this one is a function. Okay, and what about the last one? Each of these x values has a corresponding y value, and it only has one. So that means 3 is also a function. Okay, now that doesn't have anything to do with slope. That's just a little bit of review of how to tell if a table is the table of a function. Okay, now let's talk about what this has to do with slope. Okay, so part B is asking which of them represents a linear function. Okay, now it can't be 1 because 1 isn't any function. Okay, now this is asking specifically if any of these is a linear function. Well, what does it mean to be a linear function? It just means that the graph is a line. Okay. Now we could certainly graph all of these points and determine if this is a line, but there's actually an easier way to do this. Remember when we talked about earlier, the defining feature of a line is that the slope is always the same. Okay, so we're going to look at the slope for each of these points. So this change in x is 1, this change in x is 1, this change in x is 1, and this change is 1. Okay, then we're going to look at the change in y. So this change in y is 2. Okay, this change in y is 3. This change in y is 3, and this change in y is 3. Okay, so you can see, right, that the slope between -2, 1 and -1, 3 is different than the slope between the rest of the points. Okay, so this is not a line. It is a function, but it's not a linear function. Okay, let's look at part 3. Okay, the change again is going to be 1 for the change in x everywhere. Okay, now when we look at the change in y, here it's 2, here it's 6, right here it's 18, and here it's, oh, I don't even know, 81 minus 27, 54. Okay, so this is absolutely not a line. Okay, so none of these is a linear function. Okay, just for an example, something that might be a linear function is if you had something like 2, 4, 6, 8. Okay, so you have something where the change in x again is 1. Okay, and then the change is 2, 2, 2, 2. Right? You're looking for the change in y divided by the change in x to be the same. So 2 over 1, 2 over 1, 2 over 1, 2 over 1. Okay, so this is a linear function. Okay, I just want to point out that linear is not the same as having a pattern. This has a pattern. That doesn't make it a linear function. Okay, you have to find the slope and show that the slope is the same between all the points. Okay. All right, I hope that reminded you of some things about slope and you got to see some types of examples that you haven't seen before. I will see you guys soon.